Welcome to Pomodoro Joe for Friday, March 24th, 2023. Today we're doing LeetCode problem 1466, reorder routes to make all paths lead to city 0. All right, and we're given a description here. So this is a medium problem, and it says there are n cities numbered from 0 to n-1, and n-1 roads such that there is only one way to travel between two different cities. This network forms a tree. All right. Last year, the Ministry of Transport decided to orient the roads in one direction because they are too narrow. Roads are represented by connections, where connections index I equals AB represents a road from city A to city B. So that is directional. This year, there will be a big event in the capital city, City 0, and many people want to travel to this city. Your task consists of reordering some of the roads such that each city can visit City 0. Return the minimum number of edges changed. It is guaranteed that each city can reach City 0 after the reorder. All right, let's see. So we have a big party going on at City 0, and we all want to get there. But some of these roads are one way, and they're leading away from City 0. We're going to have to flip those roads. All right, here's an example here. We've got City 0, it leads out to 1, 3, and then 2 leads to 3, but you can't get from 3 back to 0 unless you flip the road. But flipping the road, you can get from 3 to 1 and 1 to 0. Alternatively, we have a road coming in from 4, which is great, but 4 also leads to 5, and there's no way back. So we have to flip that road to go from 5 to 4, which then leads us back to 0. So what this looks like is a tree with the root at 0, and we want to have all the roads flowing back to the root. Okay, we'll put 25 minutes on the Pomodoro timer and get started. So I think for this one, we'll treat this kind of like a depth first search. We'll be basically saying, let's start at root 0, or start at city 0, and look at all the connected cities. What are the cities that are connected to city 0? Once we know the cities that are connected to City 0, we'll check to see if the roads are flowing in the right direction. They should be flowing to City 0. If they don't flow to City 0, we're going to have to flip that road. And then we'll push those cities onto our stack to evaluate those cities. So all the roads then that are connected to these cities should either be flowing into that city or flowing out to node 0. Okay, so this is going to be a little bit tricky. We're going to have to keep track of whether or not we've visited cities, but if we start at City 0 and keep going down one level at a time, then we should be able to keep track of essentially the visited cities are the directions we want to be flowing to. So with that, we will get started. We'll have some result. We'll set it equal to 0 to start with, and we will return that result at the end. Next, we'll want to get our connections into a form that's a little bit more usable. So I'm going to break this out into two separate pieces. So roads to the city. So let's see, that's going to be a dictionary where the key will be the city and the value will be cities that lead to this city. So these are all roads that are going to the city. Now we'll also need to keep track of roads from the city. This will be a I should make this a default dictionary, shouldn't I? Yeah, so I will make these default dictionaries. And let's see, we'll make this a set. It'll be the set of all cities that have roads that lead to this city. And similarly, we'll have a default dictionary of all the roads that lead away from this city. All right, so the city is still the key, but now our value is cities we can reach from this city. I spelled cities wrong. Nuts. Okay, so now we have our two sets of roads. we'll go for every connection, and in fact, we can just say for every A, B in connections. We can say roads from the city A, we'll just add city B, and roads to the city. Now it's to city B, they come from city A. All right, so roads that go from the city go out to city B, and roads, let's see, nope, I had this wrong. Roads that go to city, no, I had this right. Roads going to city B are coming from city A. Okay, so now we have our roads in some format that's a little bit easier to use. Now we do the depth first search part. So for standard depth first search, we're going to need two things. We'll have a visited, and this will make it a set. And we'll need our queue or our stack. Let's call it a queue. And we'll start with city 0. So we're going to go from city 0 out to all the connecting cities and check to see if we need to flip the roads. Then if we do need to flip the roads, we'll flip the road and we'll add our cities to our queue. So we'll process those cities, check all of their connected cities, flipping roads if we need to. Okay, so while we still have some cities in our queue, we'll grab a city. Okay, so we pop a city out of the queue. If we visited the city, then we can just move on. Otherwise, we need to add this city to our visited list here, or set, I should say. Okay, now this is where we get down to our different roads. So if these are roads that are coming to the city, then that's good because we're starting at city 0. You can see we want roads coming to our city. So let's see, for roads, let's see, I'll call this for previous city and roads to our city. So these are the cities that are coming into our city. So the previous city was the city we were at. Our current city is the city we're coming to. So let's see, roads to city, our city. Now let's see, if the previous city is visited, we're okay. If it's not visited, then we'll need to add that to our list. Okay. So if we haven't visited that previous city, that means we haven't processed it yet. We'll need to process that city. So we'll add it to our queue. All right. And if we have processed it, does that mean anything? I don't think it matters. I think if we've already processed the city, it should be fine. It's coming into our current city. I think we're all good. Okay. Now what about the next cities? Okay, for the next city, so these are all the cities that we can go to from this current city. So these are all the cities in our roads from city. Now, if these are not visited yet, that means we haven't gone there. Let's see, if they are visited, I think this is the tricky part. So these are the cities that we can go to. Now, if we're looking at our city 0 to start with, we can go to city 1. And we need to flip that around, but we haven't visited city 1 yet. So I think that's our key. If we haven't visited this city, it means it's lower in our tree. So we need to go away from that city and we'll need to flip the road. So let's see, if our next city not in visited, That means it's lower in our tree, but we're going away, which is not the direction we want to go. So we'll need to flip that road. So do result plus 1. That's one road we need to flip. And then we will, let's see, add this city to our queue. All right, and if it's already in our visited list, we've already processed it. I don't think we need to do anything. I think that's right. All right, let's see if this works. I feel like I'm missing something. Missing an S, that's what I'm missing. Okay, let's try that again. Oh, it works. Well, let's submit this and see how we do. Hey, we do all right. We pass and we beat 51% for runtime and 63% for memory. That's not too bad. All right, let's see if we can improve on this any. So let's just review this really quick. So we have a list of roads that go to our city and a list of roads that lead away from our city. Because we're starting at city 0, we want basically all the roads to be leading to our city 0. So that means in our first pass through here, we want to check, are these cities leading away or leading to our city? If they're leading to our city, but we haven't visited them yet, then we need to make sure that we visit that city. Okay, that makes sense. It means it's lower in our tree, but we've already established that it's leading to us, which is the right direction. So we just need to say, we need to process this city. If we're looking at roads that lead away from our current city, this city has already been visited, which means it's higher up in the tree. If we're going away from this node and that city that we're going to isn't invisited, meaning it's not higher up in the tree, then that's going the wrong direction. We're going down the tree. So we need to flip our road, and then we still need to process the city. So one thought is maybe instead of having two separate dictionaries, we could have just one dictionary and combine these into, I guess, a little bit more complicated logic, but it'll be very similar. It just won't be as easy to separate previous and next cities. The other thing we can do is this visited set. We could just have an array here instead of a set. That might help. Actually, let's try that. Instead of keeping a set of visited, let's just have an array. And we'll just say we haven't visited any of these n cities. So the index will be our city number, and the value will be whether or not we visited it. So instead of saying if the city is invisited, we can just say if, let's see, if visited at city. And then instead of saying add, we can just set it to true here. And then down here, instead of saying if it's invisited, we can just say if visited at previous city's index. Same thing here. Instead of saying if next city is in our visited set, we'll just check visited at our next city index. And in this case, let's see, this is not. So I want to say if it's not invisited. We can say equals false, or we can say not. I don't know if one's faster than the other. Let's try this. This still works. Let's see if this gives us any kind of boost in our runtime. Oh, it does. Now we're up to, let's see, 82% for runtime and 63% for memory. So changing from a set to an array here does actually give us a little bit of a boost. All right, we still have about 12 minutes, so let's see if we can tackle the harder problem, reducing these into one list. Okay, let's do this one step at a time. So instead of having two separate dictionaries here, we'll have just a roads. And we can either make this a dictionary. Yeah, let's make it a dictionary to start with. It will also be a default dictionary. Let's see. Instead of a set, though, I think we'll have a list. I'm not sure it really matters. Let's go with a list because I think it makes more sense. So we have a default dictionary with a list as its type. And the key here will still be the city, but the value will just be all the roads to or from the city. Okay, then in here, we'll say roads for A. We'll just append B. Actually, no, we don't want to append B. We'll append the entire connection. So this will be, well, let's see, I guess we'll just make a new AB here. We can clean this up later. And then roads B will append, again, it's still AB. We're just keeping the road as it is. So the roads for A will have all the roads that lead to A and all the roads that lead from A. And the roads at B will also have all the roads that lead to and from B. So every entry in our roads will have all the roads that are connected to it, regardless of their direction. So that means down here, instead of having this roads to city, we'll have something more like, let's see, for a road in roads for our city. So now these are all the roads both to and from our city. All right, so this is where it gets a little tricky. For every road in our roads of this city, we'll have to find out if it's leading to the city or away from the city. So we can do that by saying if the road at index 0 is equal to our city, then we know it's leading from our city, which is going to be this option down here. Let's try to keep these in the same order. So let's do this. If road 1 is equal to our city, that means it's leading to our city. Road 0 leads to road 1, which means this is leading to our city. So that means our previous city here is equal to road 0. And we can do the same thing we did here. So if our previous city has been visited or has not been visited, then we'll need to process that city. All right. That means that if road 1 is not our city, then our city must be road 0, which means that we are in the roads from our city situation. So we just need to assign next city is equal to road 1. And we'll do the same thing we did down here. Okay, so let's just take a look at these side by side. So we have for every road in all the roads that lead to our city, is this road going to our city or coming from our city? Well, if it's going to our city, then road 1 will be equal to our city. And the previous city was the road at index 0. So it's this situation here. So we'll check to see if we visited this previous city, and if we haven't, then we will add it to our queue. We need to visit this city. And then the next city, basically, it's the same process. We say, if we have a next city to go to, and we haven't yet visited that city, then we'll need to flip this road around and add that city to our queue. So these two things are equivalent. But it does help us reduce this overhead. We can get rid of both of these. And we can get rid of this. And in fact, now that we got rid of those other pieces, this AB doesn't need to be broken out anymore. We can just say for every road in our connections, we can just add our road here. Okay, so I did change a lot, but it's just rearranging. It's not a lot of actual functionality changes here. Oh, of course, this needs to be road 0. And this has to be road 1. Okay, hopefully that does it. Did I forget to assign the previous? No, I had the wrong operator there. There we go. Moving fast, lots of typos. Let's see if this gets us any type of gains. And it does. Now we're at 92% for runtime and 79% for memory. That's great. We took this same algorithm from a 51% runtime, 63%, up to an 82% for runtime, 63% for memory, all the way up to a 92% for runtime and a 79% for memory, just by rearranging some of our algorithm. Slimming this down a little bit, making it a little bit less readable, I think, but if you go through this process, it gets you a pretty decent algorithm. You can still figure out what it's doing. Personally, I think this first one is a lot more readable. You know which roads are to and from the city. You can maybe add some comments in here to say that these are roads that are to the city and these are roads that are from the city. That might help. Anyway, we're short on time, so I'll leave it there. Hope you enjoyed this. Hope you had fun. Hope you can try this one on your own. Again, this is LeetCode 1466, reorder routes to make all path leads to city 0. All right, this has been Pomodoro Joe. Okay, hope you had fun. Hope you enjoyed this. Hope you learned something. Hope you can go out and write better code.